Welcome back to the channel. As the title implies, we're going to be working on the valve cages for this engine. There's two cages on this engine. One is the intake, which is on the top, and the exhaust, which is on the bottom. This cage arrangement is pretty unique on these Moguls. It allows the operator to switch out the cages, the valves, and then put the engine right back in service with rebuilt units, and then rework the removed ones at a later time. It's a pretty unique design, and we're going to be getting to work on them in just a minute. Well, first thing we need to do is make this mandrel shaft for grinding the valve seats in the valve cages. The way it works is the left shaft there goes down in the valve guide, centers the grinding stone in the seat, and then the shaft on the right is going to be put in a drill chuck, and then the whole assembly will be rotated. So let's get to making it. Over on the closing lathe now, I got a piece of bar stock chucked up, but it's not very round. I think it's probably hot rolled steel. I don't really know what it is. It's just a piece that I had that was long enough to make this mandrel out of. So I'm going to turn it down to the major diameter for the threads, which is the largest diameter I need, and then neck down the rest of it later then. But so we'll just make a few passes here and see if we can get this machined. And here we are on the final pass of the major diameter for the threads. This mandrel needs to have a 9/16 thread, which is kind of weird, but that's what's on the grindstones. So we're going to turn that thread here in a little bit, but got down to dimension pretty quick. The lathes run at about 400 RPM counterclockwise there. The camera just makes it look like it's moving back and forth. So just a little optical illusion there with the camera. And we'll get this turned down to dimension, and then we'll start doing some layout. Just doing a little layout work here. Nothing too precise needed here, just need to lay out some general dimensions for the features. The back there will be the drive for the drill, and then the blued area will be threads for the stone to screw on, and then the front piece here will be the guide down the valve guides. One thing you might ask is why I just don't buy a mandrel. Well, can't really buy this mandrel because these valves are pretty big by today's standards. This particular valve is 2 3/8 in diameter on the head, and then about a 1/2 inch shaft on it. So quite large by today's standards with automotive type valves. So there just isn't a lot of equipment out there that can do this. So I end up making my own mandrel here, and then we'll get to threading here in just a little bit. Here's a quick view of my setup for holding the cage in place. I needed some way to clamp it, so I came up with this here. Well, I lost the rest of my footage for machining this mandrel. I'm not sure exactly where it went, but I sure did lose it. So here's the end result. I think it turned out pretty good. It's pretty straightforward the way it works. This side is the side that will go down in the valve guide and cause the stone to be concentric to the seat. And then here's the other end where the drive will hook to the drill, and then there's the stone that will thread on to the mandrel. So here we are ready to go. Got the mandrel assembled. You can kind of see how it works here. I'm going to take a little bit of oil and oil the stone, and then oil up the guide there so it can go down in the valve guide, and then put a little oil on the seat itself. That's the intake cage. The cage is down below that OSB plywood, and this is the valve seat end sticking up. So there's how it looks. Now I just need to put the drill on it. So this will show how the process works. Just run the drill back and forth and put a grind on that valve seat. I did several passes off camera on this, and it dressed up pretty well. I think it'll hold compression just fine, but I guess we'll know when we get the engine assembled. I went ahead and did the exhaust cage off camera, so I just keep adding a little oil, and then I actually use some brake cleaner to clean the stone every once in a while, and because the cast iron just makes this fine powder that just plugs the stone if you don't keep it washed out. So anyway, it's an 80 grit stone, and I've got a 150 for a final pass, and then we'll get to working on the exhaust valve next. Well, here's kind of an odd setup. I need to thread the end of this valve. This is the exhaust valve. Somebody built this valve and they did a very good job. They just didn't finish it. The tail end there should have some threads on it, and it should have a hole for a cotter pin so it can be mounted in the engine. So I used some emery cloth in the chuck jaws to hold the head of the valve in place, and I was going to single point thread this, but it just didn't look like it was going to stay secure in there, so I'm going to do it another way. But this valve is very well made, and I decided to go ahead and finish it and use it in the engine. Here's another view of that valve. You can see that end there just isn't finished out. It needs to have some threads put on it. Well, it sure is fun to use some of my tools. Decided to use this thread cutter. It goes in the tailstock, and you can see then the die is held and then it slides relative to the tailstock, keeps everything straight. I decided to do it that way instead of trying to single point the threads, because I just didn't think I could hold it well enough in the chuck. So anyway, I could use the power of the lathe to go ahead and thread this. That's one way of doing it, but I don't like doing that in this case because, again, I'm not sure how well I can hold the head of the valve in the chucks there, so I'm just going to manually do it. Plus, I don't like to do that. It puts a lot of strain on the gearing of the lathe. This lathe was built in 1966 and is in really good shape, so I just really don't want to stress it out any more than I have to. Just no need for that. So I just need to cut some basic threads here, and I'll just do it by hand, and then we'll be done with this part. And here you can kind of see how it works. I use this bar to rotate the thread die around. If I was just using the lathe, then that could just drag on the ways, and then it would cut those threads real fast. So I'm not doing it that way. I'm doing it real manual here, so I've just got to unthread it and then try to turn it. Try to turn it a little bit by hand, but then I end up just having to use the bar, screwing it in there, and takes a while. I actually off camera switched to a smaller bar and was able to spin it around completely. This is just the bar that came with the attachment, and again, it's made for running down against the ways and then power threading it. So just not an easy thing to do right here, but I sure just wanted to take my time here. I didn't want to put any stress on the head of that valve and maybe screw it up in the lathe, because I just couldn't hold it real well in this setup. And these threads aren't real important, but I did want them to be straight and true to the stem, just so they looked proper. So I'll do the most of this threading off camera, and then we'll be over on the Bridgeport to cut the hole for the cotter pin. Over on the Bridgeport now, gonna drill the hole for the cotter pin. That's not a real high precision location there, just towards the end of the valve stem, just for a cotter pin to keep the nut from spinning off. Gonna center drill it and then drill on through. So should be the last operation for the valve, and then we'll call the valve done and be able to assemble the cages then. And here we are drilling the final cotter pin hole. It went pretty well. Just a key to have that center drill on there first, just so that the drill doesn't walk or anything. Those center drills are real rigid, so they put a nice dimple in the round material so that the drill doesn't walk around. So we'll get this drilled, and then we'll be done with this valve. Back over on the lathe, making the last part for the valve cages. I need to turn some pins for the rockers. These will be pivot pins that the rocker will pivot back and forth on, kind of like a seesaw, taking the cam lobe actuation and turning it into downforce that opens the valves. It's quite interesting to watch on these old engines. There's a lot of movement, and it's usually pretty slow, so you can track it and visually see it happen. It's quite neat to watch. So I'm just going to be turning some pins here, and then we'll assemble the cages. Here we are a few minutes into the machining process of the first pin. Again, I need to make 2 of them. I was quite pleased with how this material machined. I'm not sure exactly what it is, but I sure did get my feed rate right here for making a nice cut. I'm just going to turn it down to final dimension here and then part it off and just make 2 of them, one for each valve cage. It's quite an easy part, just one more thing done off the list for assembly. Here's a little different view of the cutting. You can see how nice that material cuts. I'm just not sure what it is, but I sure do like machining it though. Getting real close to final dimension here. I'm going to take some emery cloth and polish up that pin, and then wipe it down, and then I'll try test fitting it to the valve cage. Valve cage has these ears on it that this pin mounts in with some lock bolts and some jam nuts, and it's a real simple arrangement, but just need to make sure I get a pretty good fit on it. It's not a real high precision area of the engine, but I just want to make sure that it fits pretty good. Here's the intake cage, and you can see it slides on there real nice. So I think we're going to go with that for the fit. Doesn't need to be perfect, and it will fit in the rocker arm as well. So I think we're just going to go with that. Here I am. I took another little pass off of it, and it fits on there really nice now. So I think I'm going to go with this. I'll end up parting it off and cleaning it up a little bit, and then we'll be done. Well, here we are ready to assemble everything. I got everything painted. I'm going to take the valve, put it in the cage there with the seat, and then that's all looking good. Then the valve spring that I purchased, and then the keeper, that's the bell housing for keeping the spring in place, and then there's that nut that threads on. And you can see the pin that I made there to the right. I made 2 of those, one for each cage, and we'll put those in a minute. So just turn that down a little bit. I don't have it set right in the right place yet. Doesn't need to be yet. But then cotter pin goes through the hole, and then we spread that cotter pin a little bit, and then we're done with the valve assembly for the intake cage anyway. And now we'll take this pin, and I'm just going to mount it in there so I just don't lose it. We'll obviously have to take it back out to put the rocker in there, but then we've got these bolts, these jack bolts and jam nuts that I'll just put on there just to keep it all together for now. So I went ahead and put the exhaust cage together off screen. It goes the same way. You can see the mandrel there in the background we used for drilling, grinding the valve cages, and I think it looks pretty good. I think the intake cage looks real good, and we'll get the exhaust one done, and then we're done with this part of the engine. Well, here's both valve cages cleaned up and ready to go on the engine. Just another part ready to put on the engine. We'll be assembling it here one of these days. The next thing we'll do is we'll work on the mixer. I need to make a throttle plate for it, and a butterfly shaft, and then a spring. So we'll be doing that in the next video. But I think the cages turned out really nice, and I can't wait to put them on the engine. So thanks for watching, and like and subscribe if you like what we're doing here and want to continue on the journey of this 8-horse Mogul restoration. And I'll see you in the next video.